Algebra 2 students, this video is on the 6.8, which is the rational zero theorem. So the purpose of this assignment, if you remember the last couple problems when you were asked to just find zeros, you really didn't have a starting point. You just matter of trying to find something that works, something that gives you a remainder of zero. But this rational zero theorem says that for something to be a possible, again that key word, possible rational root, it has to be a factor of the constant divided by the factor of your leading coefficient. Factor of your constant divided by your factor of your leading coefficient. So for example, and again this comes from the skills practice on page 49, which says list all the possible rational zeros. So as far as listing all possible rational zeros, number one, the constant is 3, so it would be the factors of 3 over your factors of your leading coefficient, which for number one is 1. So your factors of 3 are 1 and 3, and then it's always going to include the positive and negative of each one. And then the factors of 1 would be positive and negative 1. Now you are going to divide each of these, so actually the ones that are possible would be a positive and negative 1 and a positive and negative 3. All right, so number 3, your coefficient, or your constant is 12, so we would have our factors of 12, which would be positive and negative 1, positive and negative 2, positive and negative 3, 4, 6, and 12. So again, several possibilities there. And then your leading coefficient is still 1, so you've got 1 on the bottom. So then you'd have positive and negative 1, positive and negative 2, positive negative 3, positive negative 4, positive and negative 6, and positive and negative 12 as possible rational zeros. Number 5, your constant is 2. So factors of 2 would be 1 and 2, because that is a prime number. Leading coefficient is 6, so it would be 1, 2, 3, and 6, including all the positives and negatives. So now your possibilities would be, that'd be positive and negative 1. You'd have positive and negative 2. And then you'd have positive and negative 1/2. Positive and negative 2 over 2, which is the same as 1. And then you'd have positive and negative 1/3. You'd have positive and negative 2/3. And then you'd have positive and negative 1/6. And you'd have positive and negative 2/6, which reduced as 1/3. So you already have that one. So you can see how your possibles can keep growing there, and you can have several different abilities. So how can we use this? So on the next couple problems, it says find all of the rational zeros. So for number 8, we would be looking at the factors of 12. So again, there's several of those, over your factors of leading coefficient, which would be 1. All right, now since it's a cubic equation, we got to just find one that works, because then if you do division, you would break it down into a quadratic, which you could solve by a different method. So we would start trying. Obviously, you might want to start with 1. If I try 1 and do this synthetically, you can see it does not work. If I would try 2, because that is from my list, you can see this does work. So that's always a good thing. So 2 is a rational zero. You are left with x squared minus x minus 6. And then instead of doing this trial and error and trying, You can solve this by factoring. You got x and x, you got one of each sign. You need a -1. I'm thinking a -3 and a +2 would work, which means your other zeros would be -2 and +3, which, as you can see, are also part of this list. And so we found 3 rational zeros of this one. And again, it is third degree. Number 12, we would have our factors of 8. So 1, 2, 4, 8, all over 1 and 3. And now it's a third degree. I got to find one of these that works. Once again, you might want to start with, you could start with 1. Bring down the 3. This is not looking good, so I would stop right there. You could try 2. You could try 4. And this is starting to look good. So perfect. You get a remainder of 0. You are left with 3x squared plus 3x plus 2. And then you could try and factor this. You'd have 3x and x. Both signs would have to be positive. 1 and 2 would be your only possibilities. And I think whichever way you try this, it ain't going to work. And so therefore, these are irrational, or could be imaginary zeros. We could use the quadratic formula for this, but for this particular problem, the +4 would be your only rational zero. I'm going to run out of time here on this video, so I'm going to make up another video with a couple other examples there.